This is an introduction to line equations. So in this video, we are going to define a linear equation, a line equation, and we're going to try to recognize linear equations apart from other equations of other curves. Then we're going to take our linear equation, we're going to solve it for one of the variables. And then finally we will graph the line equation by plotting points. Alright, so the first thing I want to do is tell you what a line equation or a linear equation is. A linear equation is any equation in x and y to the first degree. In other words, every term in that equation has to be either to the 0 degree or the first degree. So here's an example of an equation. Y equals 4x squared minus 3x plus 1. Now in this equation, you see that y is to the first degree. He's fine. 3x is to the first degree. 1 is to the 0 degree. Constants are to the 0 degree. Remember that a constant, no matter what the number, can have any number of variables sitting next to it, but they must all be raised to the 0 degree. Why is that? Well, because they don't show up. And anything raised to the 0 degree equals 1. And so any variable that's sitting there must be raised to the 0 degree, which means that my term is to the 0 degree. So this is fine, and this is fine in a linear equation, but the 4x squared would not be in a linear equation. So this equation is to the second degree, not to the first degree, so it is not linear. Here's another equation. 2 square root of x minus y equals 1. Now in this equation, y is fine, he's to the first degree, 1 is a constant, he's to the 0 degree. It appears that x is to the first degree because, underneath the root sign, he is to the first degree. But that root sign is actually an exponent. So this term is really not to the first degree. Anytime you have a square root of a variable, not a number, anytime you have a square root of a variable in your equation, then it is not linear. So this is not a line equation. Here's another one that can be a little bit confusing. Y equals 5 minus 1 over x. Now y is to the first degree. 5 is our constant to the 0 degree. And again, it appears that x is to the first degree. But remember, we have already learned that when a variable is in the denominator of a fraction, you can put it in the numerator by giving it a negative exponent. So 1 over x really equals x to the negative 1. This is not to the first degree. All right? So this equation is not linear. Well, here's an equation that is linear. And it may be hard to see that it's linear written like it is, but I can always use my distributive property to rewrite it. And then I can see that it is linear. This term is to the first degree, this is a constant to the 0 degree, and this is to the first degree. So this is a line equation. Well, let's take this linear equation and let's solve it for x, and then we'll solve it for y. Right, so 2x plus 6 equals 7y. Let's solve this for x. All that means, I'm not going to get a number answer for x. Solving an equation for a variable just means you're going to get the variable by itself on one side of the equal sign. So if I'm getting x by himself, then I'm going to have to move the 6 and the 2. Well, let's move the 6 first. Alright, after I move the 6, then I have 2x, these cancel out, equals 7y minus 6. Now all I have to move is the 2, so I'm going to divide both sides by 2. And then I get x is equal to 7y minus 6 over 2. So I have solved the equation for x. Alright, let's take that same equation, and this time let's solve that equation for y. Now, solving this equation for y is not really very difficult because the only thing I have to move is the 7. And I can divide both sides by 7 and get that job done. So, y equals 2x plus 6 over 7. Remember that I can switch these two sides because the symmetric property of equality says that's okay, and I still have the same thing. So now the equation is solved for y. Alright, well let's graph this equation. Let's make a picture of this equation just by plotting points. Later, we'll learn, and I'm going to leave it in this form to do that. Later, we'll learn some skills that make plotting points obsolete, an obsolete way to make a graph. But for right now, this is what we're going to do. So I'm going to make a table of points. Now, I get to pick any number I want for x and see what y is. All right, 0 is always a good number to pick. So I'm going to put 0 in for x and see what y equals. 2 times 0 is 0, plus 6 is 6. So 6 over 7. So y is 6/7. All right, well, let's put a negative number in for x. Let's put negative 3. All right, well, when I put negative 3 in for x, then I get negative 6 plus 6 over 7. Well, negative 6 plus 6 is 0. So 0 over 7 is 0. So when I put negative 3 in for x, I get 0 for y. Okay, let's pick a positive number for x. How about 4? All right, so we put 4 in for x. 2 times 4 is 8. 8 plus 6 is 14. 14 divided by 7 is 2. So y equals 2 when x is 4. These are all points on my line. So now I'm going to graph these points and connect them, and I will have my line. All right, so let's make some little marks. Now when you graph, you need to use graph paper. Graph paper makes sure that you are accurate. And you also need to use a ruler when you're connecting your points. And I am going to use a ruler. All right, now making my little tick marks, I'm trying to make them as exact as they would be on graph paper, but of course that's impossible to do. All right, so let's get my first point on my graph, 0, 6/7. Here's x is 0, so I'll go up 6/7. Well, that's almost 1, so I'm going to put that point right there. And then negative 3, 0. 1, 2, 3. Here's where x is negative 3, y is 0, so there's that point. And then my last point, x is 4, y is 2. All right, I want to make sure when we get there, there we go. Now I have 3 points, and I'm going to use my ruler to connect those points. And they should all line up. This is why we get 3 points. We get 3 points to make sure that we have done the math right in getting those points. If you only get 2 points, they'll always line up. You can always draw a line between 2 points. But when you get 3, then that third point assures that they, in fact, are all on the same line and you haven't made a math mistake. If they aren't on the same line, then you probably have made a math mistake. Now, one more quick line that we're going to graph. Let's suppose that we want to graph this line. Y equals, let's say, negative 2. All right, so I'm going to pick my points. Okay, so here's my x, y. I'm going to pick some x's and see what y is. Well, when x is 0, what is y? Well, my equation says that y equals negative 2. So, y equals negative 2. What if I pick negative 3 for x? Well, my equation says that y equals negative 2. What if I pick 5 for x? Well, here again, y equals negative 2, so y must be negative 2. When I graph these points, all right, I'm labeling my xy axis. Always label your axis. I'll draw some little marks out here, marks up here. This is an interesting line. It was interesting to get my points. All right. 0, negative 2. 0, negative 2 is right here. Okay. Negative 3, negative 2 is right here. I go down 2. And when I'm over here at 5, 1, 2, 3, 4, 5, I go down 2. And you can see that these 3 points are going to form a horizontal line. All right, and here's my line. Sometimes the easiest equations to work with are actually the hardest because you don't really have to do any work, but you have to understand what you're doing. All right.